Now we need to find the acceleration of B relative to A, and of course this two has two components, the normal components and the tangential component and the normal components. Okay, and for the tangential component, acceleration B relative to A is equivalent to alpha AB cross position vector B relative to A. However, in this case, our angular acceleration for AB is 0. So this is 0, and therefore there is no tangential acceleration for acceleration B relative to A, and we only left now with, and the acceleration of B relative to A is due to the normal, and this is O minus omega AB square times position vector B relative to A, and this is it's 10 radian per second minus 10 to the power of 2 squared minus 10 squared, and position B relative to A is 4i, so we have minus 400i meter per second square. Okay, it's moving that way. So you don't have to do this, I just add to that. So now we are ready to add all the, so the final answer is acceleration of B. Acceleration of B is acceleration of B relative to A plus acceleration of A. So B relative to A, we have got only this minus 400i, yeah, and then but the acceleration of A is relatively long. We had it here. It is minus 20i minus 40j's, yeah, minus 20i minus 40j, and therefore we have minus 420i minus 40j meter per second square. That is our answer for the question of, so that's our answer. Sorry, this is, I'm just carried over. So the position, the acceleration of B is equivalent to acceleration of B relative to A from our previous calculation. There is no other component except minus 400i, and then we have acceleration of A, which is we have calculated before to be minus 20i minus 40j. So we combine it together, we have got minus 420i minus 40j. And that is the answer to the questions that we posed before, which is what is from this system determine the acceleration of A and B, and we have used our understanding of rotating about a fixed axis and the general motion. Even when A is moving, we can find the relative velocity. We can treat A as though it is fixed relative to B, and we can find the angular acceleration. We will now, from that, we have formed some form of understanding of how to do the rigid body of the kinematics of rigid body, and we will now move to a relatively more complex structure.